Cloud computing is the gold standard of the current technological world, and we have seen cloud computing evolve with time. We have seen cloud computing in different service models, be it infrastructure as a service, platform as a service, or software as a service. These days, we hear serverless computing as a new form of cloud computing, where we as users do not have to worry about maintaining and monitoring servers, and servers technically do not exist for us as users. That is why Great Learning brings you this detailed video where we would be understanding serverless computing from a beginner's perspective. Before we move any further, I would like to inform you that at Great Learning we have come up with Great Learning Academy initiative, where there are 80 plus free courses that you people can register to. And on completion of these courses, you'll be getting a certification that you can add to your LinkedIn profile and even to your resumes. Even if you're looking for a meaningful conversation with an industry expert, Great Learning Academy is the right place for you. So let us get started. So let us go ahead and take a look at the agenda or offerings of today's session first. So we'd start off this session by discussing what is cloud computing, right? We'd understand why do we need cloud computing. Moving on, we would talk about what is serverless computing, understand what it is. We would discuss some of its benefits. We would discuss what AWS is. We would understand what AWS Lambda service is, which is a serverless compute service offered by AWS. And then we would get into the demo part and see how we can create Lambda functions using AWS Lambda. I believe this agenda is clear to you guys. Let us quickly get started. So first, let us try and understand what cloud computing is and why did it came into picture, right? So when you talk about cloud computing, right, let's consider this example. In order to start a business, if you go back to times where cloud computing wasn't prevalent, right, we had to actually go ahead and set up our own infrastructure. That means, one, we had to buy servers, stack of servers. Because when you talk about starting a business where you are mainly concerned with applications, you need an infrastructure that you can put your applications on, put your data on, right? And that infrastructure was supported by servers, which still is. But in those days, since we had to buy a stack of servers, one, the servers were very costly. The other part was, it was difficult to understand and maintain these servers because we did not have many resources that could actually go ahead and take care of this infrastructure. Apart from that, all these terminologies like server utilization, server hosting were quite new, especially if you go like 10 years, 15 years back from now, right? I mean, not many people know about it. So starting a business that required you to set up a server was a tedious task. Why? As I've already mentioned, you ended up paying a lot of money, right? You needed people who could maintain and monitor these servers, right? And these resources were also not available. These were some of the drawbacks that were there. One, investment in the setup heavily, investment in the resources who could maintain and monitor these servers. Now, scalability was a big issue, right? We talked about the money part here. Let's try and understand the money part from a scalability perspective as well. To do that, let me explain what scalability is first, right? So when you talk about any resource that you use on a cloud platform or any infrastructure where you have applications with you, right? So your application needs certain computation power, certain storage power, right? Where you can store your data and certain capability where your application can actually run. So to give you an example, let's consider that it is Diwali, okay? And during Diwali, we all know that people shop, right? Nowadays that we have these online businesses, there are possibilities that people shop online. So given the fact that it's Diwali, many people would want to shop. So that would mean that the servers that are delivering these goods online, right? The e-websites where you shop, e-commerce websites. Now these would experience more traffic, right? What if I have a fixed set of servers or infrastructure with me, right? There could be a possibility that my servers might be overloaded and my server is not capable enough to handle this traffic, right? In that scale or in that case, I need to upscale. That means I need to ensure that I'm adding more resources to my existing server, or I'm increasing the computation power of my server to meet these increasing needs. Now, there is a problem with this approach. Okay. One is, since I am experiencing more traffic, I have to upscale at the last moment. And my infrastructure might not be good enough, or at least it wasn't good enough like 15 years back to just go ahead and scale, right? Let's assume that you've managed to scale somehow by putting in a lot of efforts, money, resources again. Okay. What once the Diwali part is over, right? You might not experience this much amount of traffic, right? But you've already scaled up. Now scaling down could be a problem because one, you might have already paid for the resources, right? If you pay for the resources upfront, even if you scale down, your money is going waste. And if you don't scale down, your resources are not being utilized. You're still paying for the power and other maintenance stuff, right? So these were some of the problems. Not only scaling up, but scaling down was also a problem, given the fact that we were not sure about the type of traffic that our application was expecting, right? So what that meant was, after so much investment of money, so much planning, putting in so many resources, as a stakeholder, you were always involved in making these decisions, and you could never focus more on your business problems, but always on these issues. So these were some of the problems that were there before cloud computing came into picture. And with cloud computing, these problems were solved. Let's see how. See, when you talk about cloud computing, it is similar to consuming electricity. Let me tell you how, okay? Let's take a look at the definition of cloud computing for that. In simple words, what cloud computing is, it enables on-demand services like computation, storage, networking, etc., which can be accessed through the internet. And the user is not required to maintain and monitor these resources. Let me go back now. What the definition means is, what cloud computing platforms do is, basically they have these huge stack of servers that they've bought, okay? And what they want you to do is, they tell you that, okay, we'll give you computation, storage and database services in the formats that you want to use, right? Whether you want infrastructure as a service, platform as a service, whether you want software as a service, we'll give you services in those form. That means if you want infrastructure, we'll give you infrastructure. If you want platform, we'll give you platform. If you want complete software to use, we'll give you that as well. What you do is, you consume these services just like on rental basis. Once you've done consuming these resources, that is when you come back to us and pay to us for the units of services that you've consumed. Okay. So what that would do is, that would mean that you are basically renting these resources. So your money issue is solved here and here, right? Since you're using a metered usage, you'll be paying only for the resources for the time being you've consumed them, right? So that is why I said it is similar to consuming electricity. What we do with electricity is, the electricity boards provide electricity to our homes. We consume that electricity in the form of switching on our lights, our ACs, our TV sets, refrigerators, right? At the end of the month, the vendor gives us a bill saying that you've consumed these many units of electricity, pay these many units of money, right? So basically what is happening here is, our vendor, that is in this case our electricity provider, is taking care of the fact as in how electricity gets supplied to a home. It's available 24/7 or whatever time it is available, right? And at the end of the month, it also generates bill for us. What if your infrastructure services or your setup services could be provided to you for your application in this format? Wouldn't it be similar, right? So that is what cloud computing does for you. They say, we manage your resources, we take care of your scaling up, scaling down issues. We give you all the resources in a format, in an approach you want, right? You just consume them, and at the end of the month, just pay us for the resources that you've consumed, right? Or at the end of the tenure of your services, just pay us for the resources that you've consumed. Now you might wonder, as in when you talk about these cloud platforms, right? I mean, how are they providing these services to us at a cheaper price? Now, when you talk about popular cloud platforms, whether you talk about AWS, whether you talk about Google Cloud Platform, Microsoft Azure, now these people have been there in the market for like ages now, okay? And they have these huge server setups with them, also people to maintain and monitor these resources. So since they have a setup already and resources who can understand and take care of these resources, right? Why not give it to people so that people can use it as well? Their resources are also being utilized, right? And since they're charging less to us because they have the resources with them already set up, right? it becomes cheaper as a user for us as well to actually go ahead and use these resources. And once a job is done, we can always decide to release these resources. So that is what cloud computing or cloud service providers do for you. They provide services to you. One of the benefits of these services is you can access these resources across the globe. Data centers of these cloud providers are located in different parts of the world, right? And you can put your resources on these parts and you can access them using your internet. You do not have to worry about where these resources are lying or how are they lying there, right? All you do is fire up your laptop and start using these resources. So that is what cloud computing is for you in a nutshell. Okay, let us now go ahead and understand about traditional applications. Now this is where we start with a serverless computing part. We've already understood what cloud computing is, right? Okay, now let us try and understand what serverless applications are exactly, how cloud computing supports them, right? And how are they different from traditional applications that we have on our plate. So I've already talked about this scenario that existed before cloud came into picture. Now this is how the traditional applications also operate, or some of the problems that we discussed in the cloud computing part are common for the traditional applications that we had on our plate. Okay, so let's try and understand them one by one. Let's try and understand what traditional applications are exactly, and once we've understood what traditional applications are, then I would go ahead and talk about serverless computing a little before we jump into the applications part, right? So when we talk about traditional applications, guys, these are the pointers that we need to know, right? So these are basically 3-tier applications. One is your presentation layer, right? So that means this is the layer that communicates with your end user. Okay, and then you have your application layer, somewhere your application resides, and then you have your database layer. Okay, so basically what happens here is a user will throw in a particular request, right? The user will see the presentation layer. Okay, so in the presentation layer, what happens is basically we have the front end part. Then you have the application layer and the database layer, which more or less are the middleware and the backend of your application. That means your database layer basically handles all the data that is there. Application layer is where your application resides, and basically whatever processing that is required to happen on the database layer, that happens through your application layer, the communication part. Okay, so what is the problem with this approach, right? What are the shortcomings that this approach gives you, right? To explain this, let me try and draw a diagram for you, something that I'm not good at, but let me just do that. Let's just go ahead and open our paint to start with. Okay, so basically what is happening here is, let's assume that we have these two boxes with us, and both of these boxes are nothing but our front end and our back end, right? I'm not an avid drawer, not good with the paints and stuff, but let me just try my hand over it. Okay, and let's just say this is our front end. Okay, and similarly let this be our back end. Okay, so what is happening here is, see, there's a user. Okay, a user who probably has some requests that need processing. Okay, so this user, let's assume that this user wants to inquire about a particular movie, right? Let's see that user requests information about a particular movie that was doing fairly well in, let's say, 2014, or what was the best movie in 2014, right? So what will happen here is, this user will communicate with the front end part. Okay, so when you say the front end part, this is where he will see a web page or something like that, right? Say for example, IMDb is a movie rating website that gives you all the details about movies that are nice and good, right? Almost all the movies. So basically, let's assume that there's a web page like that. This user will throw in a request asking a question, or maybe to the Google browser as well, right? So this is the front end part where the user is interacting. Now, once a query is thrown in, this query basically travels to the backend, to the database where the user has the data that resides here. Okay. Now at the backend, you have your servers and all those things, right? Where the information is there. So the information is basically processed, right? The information that is processed is again thrown back to the user saying that, okay, in so year, this was the best movie that you had. Okay. So what happens is the user gets to see all that on the front end, the information part. So this is how a basic traditional application looks like. Okay. So what are the problems with this traditional application that we have on our plate? Let's try and understand that. So we've discussed some of these problems already, right? So in order to have this infrastructure in place, right? Servers that are costly, we've already discussed. Not just that, when you have a traditional application with you, or most of the cloud computing applications as well, okay? So because when you talk about cloud computing supports different kinds of infrastructures as well. Please try and understand that, okay? So here too, when you talk about cloud computing, if you talk about an infrastructure as a service, you might have to go through certain pains, right? Taking care of an operating system. So infrastructure as a service, it will give you option of launching virtual machines. So some part of it is relieved. But if you talk about on-premise infrastructure, that is where you'll have to actually go ahead and install your operating system as well. Supporting other software as well that you need to take care of. You need to install those software, put every software in place, right? Then manage the infrastructure. So when you say manage the infrastructure, what you'll have to do is you'll have to have monitoring services that take care of the log actions, right? Making sure that your code is running in the backend and stuff like that. Say, making sure that your resources, your virtual machines are healthy, your operating systems are healthy, right? Taking care of all these things. So you have to manage the infrastructure as well. You have to plan for availability and scalability. Now, this is a very crucial part. Scalability, we've discussed this, right? What scalability is. So when you talk about scalability, right? In scalability, what happens is basically we are talking about adding more resources. So cloud platforms let you do that automatically. But when you talk about serverless computing, they take auto scaling and availability to a different level. We'll discuss that as we move further. So, and when you talk about availability in particular, it is nothing but making sure that your resources are always available. This can be done by taking or ensuring that your data gets replicated somewhere and stuff like that. Okay. So that if your application goes down, you have a backup of your data somewhere. Okay. So these were some of the issues. When you talk about traditional applications, you had to plan all these things. Now, this is where serverless computing came into picture. Let's try and understand what serverless computing exactly is. Okay. First and foremost, let's try and understand this question that you see on the screen, right? Does it mean that when I say I have a serverless application with me, I won't be having servers at all that I need to look into? No, that's not true at all. So when you talk about serverless computing, okay, we are talking about the presence of server that is there. I mean, yes, obviously, if you need an application, you would be hosting it somewhere, right? But when you say serverless, an application is serverless from a developer's perspective. So a developer does not have to worry about the underlying operating system. The developer is not required to worry about the software that needs to be installed, all the logging and monitoring part. All of it is taken care by a cloud vendor in this case. So you might ask me as in how is it different from what we discussed in what is cloud computing part? It's slightly different there. When you talk about cloud computing does give you control. If you want to control these things, you can control these things, right? The operating systems, the software installation and all those parts. So how is serverless computing exactly different here? In serverless computing, what cloud platforms or cloud vendors do is they hide all the other complications that we just discussed. So when we talk about serverless computing, what it does is it gives us a freedom of ensuring that whatever complications that we just discussed, right, those get hidden under a blanket. And we as developers, all we worry about is writing a piece of code, writing a function and running that function. And all the backend activities are taken care by a vendor. So it's like creating an encapsulation for the code that you're trying to write here. Okay. So that is what serverless computing is all about. So this is how the infrastructure would look like. You won't see a lot of difference here, right? So you have your application layer, right? This is where your Lambda function would reside, okay? And all the underlying activities are hidden from you. So if you trigger small functions, small scripts, those would actually govern all the activities that you need to work on, all the coding part, okay? And all the underlying infrastructure would be taken care by a cloud vendor, by a cloud platform. So that is what serverless computing does for you precisely, okay? So this was about what serverless architecture looks like. There's not a lot to get into the details of it, okay? To give you more idea about it, once we start talking about the Lambda service that AWS offers, probably we'll throw in more light on some of these pointers. But to keep it simple, as I mentioned, you create a blanket, a template that covers all the complicacies of the application. All you worry about is writing in functions that can run directly in the environment that the cloud platform controls for you, covers for you, okay? So what are the benefits of serverless computing? Now, all the disadvantages that we discussed with the traditional application, those are taken care of here, okay? You do not have to worry about servers or operating systems, right? Your platform takes care of it. You are not charged for idle capacity, okay? So when you say you're not charged for idle capacity, try and understand how these serverless computing resources work, okay? Now, these serverless computing resources, they work for a very short duration. So each time you put in a piece of code and you run it, only then the resource would run, or the piece of code would run, and you'd be charged only for that minor little duration that you have on your plate, okay? So no charge for idle capacity means when your Lambda functions are not being used, are not being run, you won't be charged for that, right? So when I said Lambda functions, I'm talking about the Lambda service where you can create such serverless computing functions, okay? We'll discuss that as we move further. High availability, yes. So when you talk about these platforms, they ensure, as I've mentioned already, when you run that piece of code, only then you'll be using those resources, right? But what that ensures is whenever you run that piece of code, you'll have all these resources that are made available to you. When you talk about these Lambda functions or these serverless computing codes, they run in a very short duration, okay? So they're very fast. So if you have speedy requirements, speedy processing, it can be taken care by these kind of functions, okay? And since they run for a very short duration, you are charged for that very short duration only. And the fact that you are making them run for a short duration, you have a setup in place that ensures that the data is always available for you. The resources are always available for you in that duration. Managed scaling. We've talked about scaling already, right? So auto scaling is one thing that we need to understand. When you say auto scaling, what happens is you set up your infrastructure in such a manner that whenever it experiences more traffic, it just scales up, okay? So when you talk about serverless computing, we are talking about a lot of log data and stuff like that. So if my resources just auto scale, there could be a situation where I'm charged, okay? Because I have my logs that are running continuously, and if my resources auto scale and they stay in that form, I'm paying extra money. This problem is also solved by serverless computing. What serverless computing does is it scales your resources again if and only when needed, and post that, once the function is implemented, it goes back to a state where we are not charged for all these logs and stuff that we have on a plate, okay? So that is what managed scaling is all about. So these were some of the benefits of serverless computing. Let us now go ahead and talk about AWS and understand AWS Lambda service to some extent, okay? So when we talk about AWS, Amazon Web Services is one of the best cloud service providers in the market. Now we talked about cloud computing, right? What cloud computing is, how it solves our traditional application problems, right? So when you talk about AWS, it is one of those cloud service providers that provides these cloud computing services. Why are we talking about AWS? It is one of the best cloud platforms in the world, especially when you talk about public cloud service providers. It has the highest market share. It offers most number of cloud computing services when you compare it with other platforms. There are like 250 plus services it offers. and it operates in 245 plus countries. That tells you how wider reach this platform is or has, right? Because if I ask somebody to name like 245 countries of the world, I'm sure not many of you would be able to do that. Okay, so when you say 245 countries, I'm talking about 245 regions where it serves in, basically. Okay, so it is just similar to what cloud computing definition is, right? I mean, it provides on-demand services, whether you talk about computation, storage, networking, machine learning on cloud, DevOps on cloud, right? Whether you talk about IoT on cloud, a number of other services that concern cloud computing activities. So these services are provided. It's highly cost effective and secure. When I say cost effective, it uses metered usage. What do you mean by metered usage? We've already discussed that, right? Pay as you go model, where you pay only for the resources you consume. It also provides various offers, various benefits that are there on a plate. Apart from that, what it does is it basically gives you a lot of flexibility. You have the option of choosing what resources you want to use, how much do you want to scale them, where do you want to put those resources, right? Scalability, we've discussed this point to the brim now. That is what cloud computing or AWS also offers you, similar kind of scalability. Whether you talk about horizontal scalability, that is adding more machines, or vertical scalability, where you increase the computation power to meet the demanding needs of your application. So AWS also takes care of all those things. Security, this platform is highly secure. Whether you talk about 24/7 manned security, or whether you talk about network security, where you have access or you can control basically the firewalls, encryption of your data, and identity and access management as well, ensuring that your data is secure over the network as well. Okay, availability and disaster recovery, right? Yes, when you talk about AWS, it takes care of these factors as well. Since it operates on 245 regions, countries, right? You basically can back up your data in different parts of the world, ensuring that even if one of the resources goes down, you'll always have a backup of the data with you somewhere. So this is what AWS is in a nutshell. Now let us go ahead and talk about AWS Lambda. We'll take a look at the definition and understand what AWS Lambda does for us. Once we've understood what AWS Lambda can do for us, then we'll actually go ahead and take a look at a demo that helps us implement AWS Lambda. Okay, so let's go ahead and understand AWS Lambda, what it is, right? Let's take a look at the definition of AWS Lambda. Let's see how it works to start with. So when we talk about AWS Lambda, right, what it does is it lets you run code without provisioning or managing servers, right? Something that we've already discussed, right? You pay only for the compute time you consume, and with Lambda, you can run code for virtually any type of application or backend service with zero administration, absolutely zero administration. To explain this part more to you, let's go back to our own method. Let's assume that this is you. Okay, you have a piece of code that you want to run. Okay, what you'll do is, first of all, you'll just set up a Lambda environment. Okay, now when you say you set up a Lambda environment, what you'll do is you'll have certain triggers with you, an action that you want to perform, right? And what else you'll have here is basically details about all the requests that you want to throw in. I mean, let's assume that you are a user, you are throwing in a request, right? As a user, what request would be thrown in would be, we discussed that, right? Something like a web page or something that you'd want. It could be an HTTPS request as well. Okay, so all this information is here. What we do is, for processing all this, we have a Lambda function with us. Okay, in the Lambda function, what the Lambda function will do for you is, basically the Lambda function would ensure that whatever request is thrown in, once the request is here, your Lambda function would run. It would process the request and throw back the answer to you. Now the benefit of this approach is, please note this, okay? Once the request has been approved, or not approved, but performed, Lambda will charge you only for the duration where computation happened. So this is where your Lambda function is. All the requests came in. Let's assume that your Lambda function ran for like few seconds. You'll be charged only for those few seconds. And with Lambda, all the provisioning part is taken care by your vendor. In this case, AWS, right? If you talk about Lambda, it's an AWS service. So basically your AWS will take care of all the setting up process. You do not have to worry about setting up your CloudWatch or cloud monitoring tools. You do not have to worry about setting in other services. All you do is when you want to set up a trigger, you define that your Lambda function would be communicating with a certain infrastructure. That is what you define. That's it. And once you put in a piece of code, it just starts running for you. That is what Lambda does for you exactly. Okay. Let's just go ahead and create a simple or a sample Lambda function, right? Let's see how it works. So for that, I'm going to just go ahead and switch into my AWS management console. I mistyped it. Else it gives in the suggestion part only. There you go, right? So let's just look for AWS Lambda. Guys, if you do not have an AWS free tier account, create one, right? Because there is a lot of practice that you can do using the free tier account. And since it's a free tier account, you won't be charged for any of it. Let's just go ahead and say Lambda. Okay. There you go. And let's just create a sample function, right? Let's not complicate things. Let me just say create a function. So you have options, right? You can create a template application as well. If you want to test a certain piece of code, you can browse for serverless repositories as well. Let's create a function from scratch. What this function says is start with a hello world example, the most basic one that we always do, right? Let's try and do that. Let me call it demo function. Okay. And guys, with a mere click, this is what will happen. Okay. It will create a Node.js function for me that I can use. So let's just say create. And there you go. My function, I believe, has been created. You see, it's a demo function. Guys, when you say you can add triggers and add destination, right? You can add some sources here. If you want to connect this thing to a S3 bucket, you can do that, right? If you want to add destinations, you can do that as well. That's up to you, right? Since we've created a very basic, very simple application, let me just click here. See, this is the piece of code I have here. You see, so it's a handler piece of code, right? And it's in JS. That is since we've used Node.js, right, to create that function. See, async event. Okay. To do, it says implement constant response status code 200 body JSON state hello from Lambda function. So each time I run this piece of code, it's gonna give me details about it, whether this code was executed successfully or not. Okay. So I can even actually go ahead and test this thing. I have some other options here as well, right? I can add versions and aliases if I want to. Actions, what are the actions I can perform? The same things, right? Create aliases, export functions, delete functions. Yeah, you can configure your test events from here as well. Instead, what I'm going to do is I'm going to come here and say configure events. A function can have up to 10 test events. The events are persisted, so you can switch to another computer or web browser and test your function with the same events. Okay. Create a new test event or edit the existing one. Let's say create one. Okay. Let's call it demo event. And now I'm going to say create. And there you go. It's done, to be very frank. All you do is you click on test. And this thing will see, it will give you your execution result here, there and there. Okay. If I click on details, I'll have all the information. The area below shows the result returned from the function execution. So all I did was I just put in my piece of code there, right, in the event handler. That is all I had to do. This is the body, status code is 200. That means it was executed successfully. And all the information is here if you want. Okay, resource configured 128 MB. Duration was 2.27 milliseconds. See, this is a very less time that it ran, right? I was built for 100 seconds here. So you'll be built for 100 seconds every now and then. That means to the whenever a function runs, it would mostly run in like this 100 milliseconds duration. So that is the threshold to which you're charged. So if you use more than 100, you'll be charged for like 200 milliseconds. Okay. So that is how it works. the log output, right? This section shows the logging calls in your code. Whatever logging calls were there, it would display all that for you. Okay. And then we can go ahead and take a look at other things as well. Okay. You see, if I click here, it will give me all the monitoring details that I have. I don't think we should see a lot of monitoring details. Let's just wait. Okay. So what you can do is, guys, you can basically test the same function multiple times, and then you can go back to your CloudWatch. Okay. And you can actually get all the log stream informations, right? What were the spikes, what were not the spikes and stuff like that. So you can get all the information that you need. So this is how a Lambda function works in a nutshell. I hope that you people have understood how a Lambda function works. What all can you do with a Lambda function, right? Note one thing, guys, whenever you create these resources, delete all of these. Make sure you do not keep them up and running. Lambda is not a free service. Please note that. However, if you create a free tier account, Lambda services are free for first 2 months of your usage. Okay. So make use of it. If you have a free tier account, use Lambda. Okay. And get your hands with it, so that basically you have an understanding of how it works. You can also go back to CloudWatch. In CloudWatch, you will be having your CloudWatch logs. I'm sure about that. Click on it. I need to figure out where these logs are. There you go. Lambda function. Here it is. And I'm going to say delete. So my logs will also get deleted. And last thing what happened was we also had an IAM policy that governed our accesses, right? So in roles, I think there should be a role somewhere that says AWS Lambda Demo function. There you go. So ensure you delete all these roles, right? And once you are done with deleting all these roles and resources, the last activity could not be loaded. Yeah. So I believe there's some internet issue at my place, but you just delete these resources. And once these resources are all deleted, you won't be charged any further for any of these. So there you go. This is how AWS Lambda works for you, right? So we've gone ahead and we've actually done quite a few things, right? So this brings us to the end of this video on serverless computing. In this video, we've understood what serverless computing is. We've talked about some of the benefits of using serverless computing. Then we did go ahead and take a look at a popular cloud vendor, that is Amazon Web Services, or also known as AWS. Then we've talked about a popular AWS service that supports serverless computing, that is Amazon Lambda or AWS Lambda. We hope you like this session. We would like to inform you that at Great Learning, we have come up with Great Learning Academy initiative, where there are 80 plus free courses that you people can register to. And on completion of these courses, you'd be getting a certification that you can add to your LinkedIn profile and even to your resume. If you have career related questions, then Great Learning Academy is the right place for you to interact with numerous industry experts. Thank you.